So till now we have talked about the convex mirror. We told yesterday, like in convex mirror, center of curvature and focus remains on the left side of right side of the mirror, means inside the particular polished surface. In which what happens, object is still negative, but focus and radius of curvature still remains positive. But still, this also convex mirror has four property. Okay, one normal property is there. Like if I take my convex mirror, okay, if I just take my convex mirror, what is going to happen if the light is going to fall on it, if the light is going to fall from infinity, for that case also, since the light is going to diverge from here, what we are going to observe, that they are going to meet. If I do the back tracing, they are going to meet at a point, and I call this point as a focus. Okay, means also for the image means for the object to be at infinity, what we observe, that image is still is at focus. But which kind of image it will be? It will be kind of virtual image. Okay, it is not a real image. Now next thing is that for whatever kind of light, if it falls over here on the convex surface from any angle, if it is falling, for all of these light, there will be only divergence. Okay, means there will be only possible divergences will be there. That means what is going to happen, if you backtrace all of these diverged light, they are always going to meet between this pole and focus of the convex mirror. Okay, so whatever light is going to fall from left side, means if light falls from the लेफ्ट साइड, मीन्स कोई भी लाइट अगर लेफ्ट साइड से फॉल करती है ऑन द कॉन्वेक्स मिरर, ठीक है, कोई भी लाइट अगर लेफ्ट साइड से कॉन्वेक्स मिरर के ऊपर फॉल करती है, देन वन मोस्ट इंपॉर्टेंट पॉइंट विल बी इट विल मीट बिटवीन पोल एंड फोकस. वो कहां पे मीट करिएगा? बिटवीन पोल एंड फोकस के बीच में मीट करेगी अगर लेफ्ट साइड से लाइट फॉल करती है. यही मेन एक ही बस इमेज फॉर्मेशन है, एक या दो इमेज फॉर्मेशन, और इसी के ऊपर प्रॉपर्टी होता है. बट अभी कल मैंने तुम्हें बताया था कि जो वर्चुअल इमेजेस हैं वो क्या चीज की तरह वर्क कर सकते हैं. दिस वर्चुअल इमेजेस कैन वर्क एज अ वर्चुअल ऑब्जेक्ट, कैन वर्क एज वर्चुअल ऑब्जेक्ट. सो यहाँ पे याद रखना, मीन्स एक कॉन्वेक्स मिरर के लिए एक प्रॉपर्टी है कि लाइट अगर लेफ्ट साइड से फॉल करती है तो उसके लिए वर्चुअल इमेज बन गया. बट हमें पता है कि वर्चुअल इमेज एक वर्चुअल ऑब्जेक्ट की तरह वर्क कर सकता है, और जब वो वर्चुअल ऑब्जेक्ट की तरह वर्क करेगा, देन क्या होगा, उसके लिए अलग अलग डिफरेंट काइंड ऑफ इमेज फॉर्मेशन आएंगे. ठीक है ना? तो उन सारे इमेज फॉर्मेशन के बारे में हम डिस्कस करने वाले हैं. गगन, इज इट ओके और नॉट? टेल मी यस और नो. Yes or no? Okay.
Yes, sir.
Okay. So based upon this, we are going to talk about different reasons of the particular concave mirror. So reason one. So when light is falling, try to see this. This is my object, finite length object. Okay. And for it, what is happening? Light is falling on the convex mirror from the left side. When light is falling from the convex mirror from the left side, it is again diverges back in the, means it is reflected by towards the opposite direction of incident ray. What we observe, if we backtrace it, it is going to meet at a point which is going to lie between this pole and focus of the concave mirror. This image will be virtual. First important thing, that image is virtual. Second, it is erect, means it is lying head up. Okay. Second, third important point, it is smaller in size. Means सबसे पहले तो virtual होगा, दूसरी बात सीधा खड़ा रहेगा, और तीसरी बात सबसे छोटा इमेज बनेगा. ठीक है ना? तो हरदम concave mirror produces convex mirror produces diminished images of real objects. ठीक है ना? इन सारे पॉइंट्स को लिख लेना. ठीक है? क्या करता है कॉन्वेक्स मिरर? इट प्रोड्यूसेस डिमिनिश्ड इमेजेस ऑफ रियल ऑब्जेक्ट्स. इसको लिख लो एक बार, एक मिनट में इसको शेयर कर देता हूं. Okay, let me just share this Telegram also. Okay, done. Okay, now Second point is that I know that these virtual images can work as virtual objects. When they are going to work as virtual objects, I will have three different cases. So first case, reason two I'm going to take. I took my virtual object. When I placed it before the concave mirror, for this virtual object, what is going to happen, since this kind of lights are going to fall and they will be diverged, like this was my original reflected angle. Okay. Second property, when the light falls like this way, it will be reflected like along this way. Okay. And for this incident ray, I will have the one reflected light over here. What we observe that for this virtual image, which is treated as virtual object, I form one real image over here. I am forming one particular real image over here in the left side of the mirror. Got it or not? Left side of. So for virtual object between pole and focus of convex mirror. Okay, again try to understand this is very much important, that if a virtual object is considered between pole and focus of a convex mirror, I'll get an image. There will be an image will be formed real, erect, and it will be enlarged. Got it or not? Remember that this image, we can't say about this distance, where this distance will be. Okay, because we are not aware that how much enlarged it will be. Got it or not? It depends upon this virtual object. Understood or not? So this image will be real, erect, and enlarged, and it will be towards the left side of convex mirror. Got it or not, girl? Tell me. Gagan, are you able to understand or not? Hello? Hello?
Sir,
Are you able to understand this or not?
sir, doubt, sir.
Tell me.
Sir, they have given as the object moves towards the pole, magnification increases and tends to unity at a pole.
uh, as the object moves towards a magnification increases and tends to unity at
Uh, Pole. Sir, which means that when the object is kept at pole, what happens? Like the image will also fall on the pole itself.
Hmm, but actually, if I see why this magnification is unity over here, okay? Actually, magnification is not. See, if you see the magnification minus of v by u, this is totally different thing. Okay, means here the magnification is in terms of height they are talking, but not. So if I write magnification is equal to minus of v by u, then this case will not be applicable. Whatever written over here, it is not applicable. But if I
Sir,
say,
sir, but
uh,
sir, but it means that the maximum image of the maximum size of the image would be the size
correct,
of the object itself.
yeah,
It
see,
can't further
uh,
enlarge than the object.
means at pole, if I try to understand, if I fix it at pole, image will be also formed at pole or not? Tell me so. So what is going to happen? The
Yes, sir.
height of the particular
Sir.
image will be similar to the height of pole or not? Tell me what is happening. Try to see. When I considered it, the when object was at infinity, a very small image was formed at focus or not? Yes or no? Yes or no? Tell me. When the object starts to approach over here, what is going to happen? The image will be formed between pole and focus. That means what? The object is moving towards the mirror, the image is moving towards the pole. This is what happens or not? Relative speed. Jagan? Yes or no? If the object moves towards
Sir,
this, tell me now.
sir, but when we are talking about linear like magnification of that magnification, sir, we are telling that magnification is equal to minus v by u.
Yeah.
Object image distance upon by object distance, but
Huh.
when we take the height as an height, like sir, height of the image by height of the image upon by
Gagan,
height of the object, then the ratio will change, right?
no, no, no. See, this magnification, try to understand. This is my image distance, this is my object distance. Image distance will be positive or not, tell me. Right side of the mirror, and also it's
Yes,
the
sir.
direction of the incident. So image distance is positive. What remains negative? Object distance will remain negative in this first reason or not? Tell me yes or no. So this will become positive v by u or not according to the sign conventions. This is what they are telling. This ratio, this particular magnification ratio increases. Got it or not? Means what you are observing, try to understand. See, when I'm doing this. I'll take one paper. Okay? Understand this. Okay. So this is my concave mirror. So when the object was at infinity, means if the object was at infinity, light will come parallelly, yes or no? Light will hit parallel, because for object at infinity, light must come parallelly, then only it can fall on the mirror. Okay, now next thing, it reflects back along this direction, means it diverges. When it is diverging, what you observe, what you are going to observe, that when you are going to do the back tracing, they're going to meet at a point, and that point I call it as focus. So try to understand, for object at infinity, very much large distance, I'm getting an image on the focus which is very much less in size, very less in size as compared to other things. Now, what is happening next? That when you are bringing the object over here, means let's suppose I brought the object near this pole. Okay. For the object over here, what is going to happen? An image will be created between the pole and the focus. Got it? Got it. Means where it will be created? Between the pole, means this point, at this point, the image will be created. This is my pole, this is my focus. So for an object nearer the pole, I get an image over here. If the object moves much more nearer, image will come. Let's suppose if the object is here, image will come much more nearer towards the pole. If the image moves further forward, if the object moves further forward, again it will come much more nearer to the pole. So what you observe, this is zero size, diminished. This is little bit enlarged as compared to, as comparison to this or not? Tell me yes or no, Gagan.
Yes, sir.
यस और नो? मींस ये थोड़ा सा बड़ा हो गया ना, इस ये तो सबसे छोटा बना, ये तो सबसे इंफिनिटी के लिए सबसे छोटा इमेज बना। उसके बाद जैसे ही ऑब्जेक्ट थोड़ा सा हम दूर रखते हैं, उसके लिए थोड़ा सा बड़ा इमेज, जैसे तुम और नजदीक लाते हो ऑब्जेक्ट को, उसके लिए थोड़ा और बड़ा इमेज, जैसे ही इसको और नजदीक लेकर आते हो, एकदम से बड़ा इमेज, और जैसे ही तुम इस ऑब्जेक्ट को पोल के ऊपर लाके खड़ा कर दोगे, तो इमेज भी कैसा बनेगा? सेम साइज का बन जाएगा। तो यहाँ पे क्या नोटिस कर रहे हो? इमेज की जो,
Yes, sir. Yes, sir.
इमेज की जो साइज है वो बढ़ रही है कि नहीं बढ़ रही है? सो दैट इज व्हाई मैग्निफिकेशन इज इंक्रीजिंग। Magnification increases. And also you try to see, magnification is nothing but minus of v by u. U is negative over here for an object placed on the left side. So minus of v
Sir.
plus minus of u will be what? Positive v by u or not? Tell me yes or no, Gagan. So
Sir.
if you
But
decrease, try to understand. If you decrease the object distance, magnification should increase or not? Tell me.
Sir, but like if you are saying, sir, you are saying as the object comes nearer the pole, even the image also comes nearer the pole. So at some time they will become equal height.
Yeah, at on the pole only
Sir.
it will become equal height. On the
Yes, sir. Sir, which means that the object, the size of the object, the maximum size attained by the object will be the height of the size of the object itself. Image object size will be equal to the object. That is the
that is
maximum.
that is why na, it is saying that, tell me Gagan, always every time the maximum magnification possible for these kind of virtual images is always equal to, try to understand, if someone asks you what is the magnification of a plane mirror, it is equal to 1. Why? Because the object height is equal to image height. So that means
Yes, sir. But in case of convex lenses, in case of concave lenses,
it's
it
different.
can be like like
More
it
than
can be
one.
infinity, right?
Yeah, that's what I'm saying. Now, in case of concave, it can be infinity, but in case of convex, the maximum magnification can be attained is equal to the unity. Means the object height can be equal to the virtual image height. Understood or not? Yeah, try to understand. Got it or not? Okay. So that is what it is.
Yes, sir.
The maximum height it can be, maximum magnification can be unity. Okay. Got it or not? Yes or no?
Yes, sir. Yes, sir. Understood, sir.
Okay. So for reason 2, what is going to happen? Virtual object is placed between pole and focus. So for concave mirror, if I place my virtual object between pole and focus, I'm going to get a virtual image over here. Okay. Sorry, real image over here, which is erect and enlarged. Okay. If the object is moved away from the pole, like let's suppose if I move this away, the object from pole, then only this image height increases. Got it? So that means what it is saying, if you have concave mirror, okay, this is my pole, this is my focus. If I place my object over here, I get one real image for this object. Okay. Now, if we remove this pole away from, this means if you move this pole away, what is going to happen? More divergence will be seen. More divergence means what? More enlarged real image I'm going to get. So that means what? If I move the object, if I move virtual object, away from pole, the image becomes more enlarged. Got it or not? Understood or not? So these are the case
Sir,
of virtual objects here.
sir, if as the virtual object is moved from the pole, sir, the size of the virtual object decreases, or
No, no,
it
no.
will remain same.
I'll kill you. Size of the how
Sir,
come the size of object will change? Huh?
sir, because it is virtual object, right?
Huh?
It is formed from the it is not formed by real like real light
What we are considering, see,
con
try to understand for all of the cases over here, for all of the cases we can move this virtual object between pole and focus. So let's suppose if at a constant size I am moving it, okay, means for I have attained such a way that it is a constant size, and for that case if I'm trying to enlarge, okay, so what will happen, the divergence will increase or not, whatever, let's suppose if the object size also decreases over here, still the divergence is going to increase, and for that I will have a much more enlarged image over here. Got it or not? Okay. Understood or not?
Yes,
Why?
sir. Understood, sir.
Because the
Yes, sir.
divergence will increase. Okay. So that is the main property. Next thing. So can I move to reason 3? So let us move to reason 3. Little bit, I'll just dark this. This is my concave mirror. Okay. This is my principal axis. And I have placed an object over here. Okay. Between the focus and the center of curvature. Okay. So I have an object, means virtual object between the focus and the curvature of it. Means remember that uh, it is erect in nature. Okay. So for this case, what kind of image I'm going to get? This is my concave mirror itself. So this was the question of JEE Advanced 2013, I think. When a virtual object is placed between focus and curvature, okay, inside the convex mirror, what kind of image are you get? Any idea? We just check on YouTube what is happening. Hmm? Can you tell me what is going to happen, Gagan? Any idea? Okay, so this is one of the most crucial cases over here. Okay, means if you ask me, sir, Anurag sir, how is this possible? Also, so I can't give a proper explanation of this problem. So if I place one object on the focus, inside this like nearer to the focus in this convex mirror, so what is going to happen? For it, I will get again an virtual image. Okay, so this is my virtual object itself. Virtual object itself. And for this virtual object, which is found between focus and curvature, this is very impossible case. Means I can say this is like 1 in 1 lakh cases. Right or not? Okay. And there are experiments. There are experiments in Newton's rings experiment in MSc when you will go. So these are experiments which are done. Okay. So there you will found that if I place between focus and curvature, I'll get an image which will be also a virtual image, but it will be inverted and enlarged. Okay. What is going to happen, Gagan? This will be inverted and enlarged. Remember that when the image, like try to understand, when the image will be formed in the similar direction, let's suppose object is in this direction and image is also formed in this direction. If you move the object, the image will go away. If you make the object towards this, the image will come towards this. But try to understand here, if this is my image, try to understand, Gagan. For this virtual object, this is my virtual object, an image is formed over here. So if this virtual object starts to move towards center of curvature, image will start to move towards this center of curvature again, yes or no, relative speed. So what is going to happen at that time? The size of the image is going to decrease or not, Gagan? Tell me, yes or no? It will decrease now. Hello, Gagan, are you there? Hello, hello. Can you hear me, Gagan? Hello, hello, hello. Is that audible now, guys? Gagan, can you hear me now?
Yes, sir. Yes, sir. Internet was off, sir. So
No problem.
current here fluctuate.
Okay, okay. Now try to see over here. What I'm saying is that let's suppose if what is the property of these images? Let's suppose if you have a concave mirror, okay. If the object is kept over here, if the image is formed, if object is moved towards this side, images move towards this side. Again, concept of relative speed will be also applied over here. Got it or not? So let's suppose if you have a virtual object over here, which is formed, which is between focus and center of curvature of convex mirror. So if I have an image, if I have an image which is formed, so if I move this object towards the center of curvature, what is going to happen? The image will also move towards the center of curvature. So if the image moves towards the center of curvature, what will happen? The image size will decrease, and if image size decreases, what is going to happen? Magnification decreases. Okay, so let's suppose this is an, I'm telling you again, these cases are not even possible in practical cases. Okay, means for all the light rays which are going to form, which are going to fall on the convex mirror, for all of them I'll get an image between focus and pole. But this is 1 by 1 lakh cases, okay, where the image will be formed and virtual image will be formed between focus and center of curvature. For that, it will be treated as virtual object, and I will get one image over here. If I move this object towards the right, the image will move towards the left, and image size decreases, which makes the magnification decreases. Understood or not, Gagan? Yes or no?
Yes, sir. Understood, sir.
Understood. Now, last case means one of the most crucial case, that is of reason 4. If I place the object beyond the center of curvature, means what happens? Your virtual image, initial virtual image, first virtual image has been created beyond the center of curvature of the convex mirror, okay, which is treated as virtual object. So if you have an virtual object beyond the center of curvature for convex mirror, what is going to happen? Again, similar concept, the image will be formed between the focus and the center of curvature. If you move the object towards this side, what is going to happen? Image will move towards left side. Okay. If you move the object towards right side, image is going to move towards left side. So if you move the object away from the center of curvature, what is going to happen? Magnification should increase. Okay. If you move, so further decrease. Wait. Let me just see. If I'm moving this object away from the center of curvature, okay. So the image moved towards the pole. Now you know, now when you are moving very much towards the pole, your size will decrease or not, Gagan? Yes or no? So what is going to happen? When you move towards the pole, your size decreases, and such that magnification also decreases. So are you aware of this? Means, are you able to see the four reasons of this concave mirror? First reason was normal reason. For this, I was getting my object between pole and focus, and if I move the object from infinity towards the pole, the image size increases, magnification was increasing. If I take the second case, if i if I take the particular second case over here, in which the virtual object was between the focus and the pole, for that case I was getting one image over here. If I move my this particular image towards the focus or towards the pole, based upon that I will get my different kind of magnifications. Gagan, are you able to understand these four cases or not?
Yes, sir.
Yes, now. So what you will have to do, you'll have to write all of these things. Means all of these: reason 1, reason 2, reason 3, reason 4. Make a short snap note. Okay, do not put much more time on it. Just based upon this, I will utilize this to draw the graph of it, and you try to see. When I have, try to understand for this concave mirror. Okay, so this is my pole, and this is my focus. Okay, this is my pole, this is my focus over here. So when a light is falling from this side, you know that it is going to fall at focus. Means for an object at infinity, what is the formula? 1 by v plus 1 by u is equal to 1 by f. I'll write in terms of sign convention. Focus remains positive, u can be negative, so actual real formula with respect to sign convention is 1 by v minus 1 by u is equal to 1 by f. This is the sign conventional formula for concave mirror. Yes or no, Gagan? Sign conventional formula for convex convex mirror. हाँ अनुज का अनुज क्लास नहीं ज्वाइन किया. का बोला था वो? हाँ, Q प्लस। हाँ, so 1 by v minus 1 by u is equal to 1 by a. Now try to understand. If I put object as minus infinity, Gagan, if I put object at minus infinity, so what I will get? I will get focal length is image of the mirror at the focus or not, image or no. But this focus will be
Yes, sir.
positive focus. So object, let's suppose if your object is at infinity, means if I am going, this is my object distance, this is my image distance. So if I place my object at infinity, if I have placed, so this is my infinity, okay, minus of infinity. So if I place my object at minus of infinity, for that I'm getting an image at the f naught in the object distance, image distance. So therefore, for these kind of cases, I'll get a graph like this way. Yes or no? Why I will get a graph like this way? You can ask me. So what is happening when object is हेलो? हाँ, मैं क्लास ले रहा हूँ. हाँ, रिकॉर्डिंग देख लियो. Okay, so what I'm saying that when object comes from minus infinity towards the pole, what you observe that image distance also decreases towards the pole or not. So actually when I'm coming from, so first for infinity the image formed over here, for less than infinity image will be formed between less than focus. For image coming much more nearer towards the pole, image will be formed over here. If I'm going much more nearer towards the pole, I'm going much more nearer towards the pole again for the image side also. Okay, so try to understand, the object is over here, this image distance decreases, the object over here, this image distance decreases, the object over here, this image distance decreases. So the more object comes from minus infinity towards the pole, the more image comes nearer to the pole, means the distance of image becomes zero. So ultimately it becomes zero over here. Okay, so this is my graph, this is my graph when the object is coming from minus infinity towards the pole. Got it or not, Gagan? Yes or no?
Yes,
Gagan,
sir.
yes or no? So now next thing is what is going to happen if you place the virtual object over here. Try to understand. If I place my virtual object at the focus, what is going to happen? If I place my virtual object at the focus, what is going to happen? Image will be formed. The real image will be formed at the infinity. Got it or not? If I move this virtual object towards the pole, what is going to happen? Image is going to move towards the pole also. Okay. Yeah. If object is moved towards the pole, image is also going to move towards the pole. So what is going to happen if you decrease the object distance? In that case, if you decrease this object distance, what is going to happen? Image distance will also be decreasing. So that is why for f naught you are getting an image at infinity, and after that its speed, its a particular distances decreases. So you have one whole graph over here. Okay, so this is for reason 1, this is for r of 2. Understood or not? Tell me, yes or no?
Yes, sir.
Right or not? Now for reason 3 and 4, this is you can try to accumulate, you can try to think like similar way, that for reason 3 and 4 what is happening when it is moved between focus and center of curvature, the image comes near the center of curvature. So if I place the virtual object at center of curvature, image will be also formed at center of curvature. So if I place my virtual object at center of curvature, what is going to happen? The image will be also formed at center of curvature. So this will be my midpoint. After that, you try to see when I move from center of curvature towards the focus, what is going to happen? The image sizes increases or not? Image or not? So that is why, what is going to happen when you are moving from this center of curvature towards the focus? This is my center of curvature of the object distance. This is my focus. So when I'm moving from center of curvature towards the object distance, what is happening? The image sizes increases. The image sizes becomes enlarged. Yes or no, Gagan? So this is for R3. Okay. When I move much more away from the center of curvature, what is happening? Try to see. When I'm moving much more away from the center of curvature, image is, see this image has been formed between focus and center of curvature. If I go at infinity in this particular reason 4, what will happen? The image will be very much formed diminished. So what will happen? This is my center of curvature, this object is at infinity. Light is going to fall like this way, and it will be converged over here. So this will be my formed at focus. Got it or not? So when you are moving away from the center of curvature, what is happening? The size of the image, this image distance or the image distance is decreasing from center of curvature towards the focus. Understood or not? So this is for R4 of the convex mirror. Understood, Gagan, or not? Tell me all of this property of the one by V, one by means V by U for convex mirror. Yes or no? Are you able to understand this graph?
Yes, sir.
Got now?
Yes, sir.
This has been asked in JEE Advanced 2019. Okay. So you have to think all of these kind of things. Means this R1, R2, R3, R4, no one will be able to make you understand until unless you try to draw the graph of, you try to draw the ray diagram for all of these reasons. So this was all about convex mirror, and this was all about concave mirror. You can your only homework will be just one homework for is to think about your critical ability. Just you have to draw what is the graph of. It is available in any. It is not available in any kind of book. The graph of 1 by V versus 1 by U for convex mirror. Okay, you have to draw and send me till afternoon. Got it or not? After that, tomorrow magnification, longitudinal and transversal I will complete. Okay, and aerial magnification and cutting of spherical mirrors. After that, velocity of image, and we will solve the problems. Got it or not? Today, I think I'll take
Yes,
one
sir.
more class in the evening. Okay.
Yes, sir.
Okay. Yeah. Okay. तब तक के लिए बाय बाय. Good night. Take sorry. Bye bye. Take care. Okay.